In this tutorial, I'm going to be going over the PhaseSpace server code for the Spot 2.0 software. So to access the server code, navigate to the Spot 2.0 directory, open up the PhaseSpace server, and you'll see all of the code is located here. To actually see the code, open up the Stream Data solution. Remember, you need Visual Studios to do this. And then double-click on the streamdata.cc. Inside here, you should have all of the C code required to run the PhaseSpace server. So everything at the beginning, before the main function, is just the libraries and headers required to actually run this code. So starting in the main function here, we have a bunch of variables that we need to declare. The only ones of real concern here are the port number, which may need to change if you want to change the port, and then the actual size of the data packet. Here, 13. So if you want to increase the number of packets you can send, you'll have to increase that number. So the first block here we have is the IP address of the ground station computer. If you're using the live computer, this should never ever change. However, if you want to set up your own personal computer as the ground station and run the software from there, which is totally possible, you do have to update the ground station computer to match your IP address. To find your IP address, you can just open the command prompt and then type ipconfig, and you'll see your IP address is located in your Wi-Fi adapter, which in my case is 192.168.0.105. Here we have the IP address of the client. This is no longer used. And then from lines 80 all the way down to line 128 is the UDP block code. So this basically creates a socket and then binds it such that we can send data through it. So this should never change as well. Then we have the actual loop that checks for a handshake. So basically all this is doing is it's checking every loop to see if it's actually received any data bytes from the expected client. If not, it keeps looping, and once it does, it exits the loop. Then we start with the actual PhaseSpace code, which begins here. So we define the IP address of the PhaseSpace, which is 109, and then we just define some variables, and we open a socket. All of this is variable definitions, and we set the profile of LEDs we want to use. So the all 120 basically means look for all available LEDs and connect to those. You could set your own custom profile if you want, but it doesn't really provide any benefits. So here we have the actual definition of the LED locations relative to the CG. This will have to change if you want to add or remove mass from the platforms, especially if it has a long moment arm. So for example, if you want to add a robot arm and you want to get accurate data, you have to update these values. Now, these CG relative locations are then binded to LED identification numbers. So for red we have 1, 5, 3, and 7. For the arm we have 2, 6, and 0, and for the black we have 15, 9, 11, and 13. On line 218, we have the frequency of the PhaseSpace server. Right now it's set to 50, but since most diagrams run at 10 Hz, we want it to be less than that, so we will set it to 5. If we set this value to something greater than the frequency of the Simulink diagram, it's going to cause the data to back up, and we will no longer be able to run the system in real time. This line of code on 221 is the streaming settings, so we have the option of setting it to 1, 2, or 3. 1 and 2 are different variations on UDP communication protocols, and 3 is TCP. So we want to use UDP. And then we initialize our clock. So then we enter the actual PhaseSpace loop. So the first step is to connect, and then check if there's an event, which basically means is there a data packet available. If there is no data packet available on this loop, skip to the next loop. If there is a data packet available, but it has an error message, then break the loop. Otherwise, check for rigid bodies. So the rigid bodies are the ones defined with CG locations. So we have the red and platform, which are considered rigid bodies. So the red platform has red ID 0, which we defined right here. Arm has 1, black has 2. So for rigid body with ID 0, grab the X and Y position and then the attitude. For ID 2, grab the X and Y position and the attitude and store it in a different packet location. Then check for markers and grab the X and Y locations of each LED. So this is the elbow X and Y, wrist X and Y, and end effector X and Y. But of course this can change to whatever you want it to be. It's just defined this way because that's what was required for my thesis. And then once you've gotten all your data packet values, you send out the data packet to the client. So if there's nothing available, it will send back a 0, and then in the Simulink, just the way that it works, it will hold the value that you had before if you receive a 0, or basically a null packet. And then once this loop is done, we can just close and clean up the socket. So once again, just to summarize the important bits, if you're starting this on a new computer and you want to make it the ground station, you have to update the IP address. If you want to add more data, you have to add a data packet. If you want to update the CG, you need to do it here. Note that these are all measured in millimeters, and this is using the reference frame defined in the user manual, but it's also defined here, so top left, bottom left, which top left meaning the top left relative to where the x-axis is pointing on the body. And then you would also consider changing the frequency. If you want to run this at a higher frequency, you would put this at, say, 50 if you want to run it at 100. So once you've prepared this in a way that you want, you just go build solution. And then you can find the actual solution in x64, release, and stream data. So once you have your executable, you copy it and you go to the actual code. So let's say that we want to update the example we developed in the previous video, and we would just copy it in here. Of course, as I'll go over in the next video, you'll have to update the frequency here if you want to increase the frequency of the PhaseSpace server. But that basically covers everything you need to know about the PhaseSpace server code, aside from going over the device driver blocks. So in the next video, I'm going to start to cover the template diagram and any other code that is located in the source code folder.